In section 6.1, we're going to be solving something called a systems of equations. So up to this point, when we've been solving equations, we've just had one variable that we were solving for. So like, a simple example that we've done up to this point, maybe we had, say, 2x plus 9 is equal to 11. So we could solve this equation for x. But the main point is that we're only solving this for one variable. There's one variable here, only the x, and that's the only thing we're solving for. In this section, we're solving equations that look like this. So say if we could have like maybe 2x plus y is equal to 10, and maybe x minus y is equal to 3. So here we have two equations and two variables we're solving for. We need to figure out what this x is, and we also have to figure out what this y is. And we have to do that by using both of these two equations. So whereas before we just had one equation and one variable, now we're going to have two equations and two variables. So we want to figure out what x is, and we also want to figure out what y is. And in order to do that, there's three different ways. The first way we're going to talk about is solving this by graphing. So solving systems by graphing. So in general, how we do this, so say if we have our system of equations, well, we could have two equations. Say y is equal to m1x plus b1, and then y is equal to m2x plus b2. So remember, y equals mx plus b, that's just a line. So these are two lines. Here's the slope, the thing attached to the x. So this is slope m1. Here's your y-intercept b1. Here's your second line, has a slope m2 and has your y-intercept b2. So when we're solving this system of equations by graphing, what we want to do is first just graph these two lines. And then there's going to be one of three situations that's going to happen. So let's call this one line 1, and this one's going to be line 2. So the first situation that could happen when we're graphing, so say if we graph this, here's the first line, looks something like this. And then we do the second one, maybe it looks something like that. After we graph these two things, we see that these two lines intersect at this one point right here. If this is the situation that happens, then the point where it intersects, this point right here, that's going to be the solution. So the solution is just a point. So it has an x coordinate, it has a y coordinate. So this point is the point x comma y. And we say that point is going to be the solution of the systems of equations. That's the first thing that can happen. The second thing that can happen is when we graph these two lines. Well, we can graph these and we could see something like, say if the first one looks like this, and then the second one looks like that. So they never intersect, they're parallel. So when this happens, we say there's no solution because there's never a point where these things touch each other. And if it never touches each other, we said a second ago where it touches, at this point, that's the solution. These ones never touch each other, so this one's going to be no solution. So this one over here, this one is one solution, and this one's going to be no solution. So our third situation that can happen, well, we have so two lines. So say if we draw the first one, maybe it looks like that. And we draw the second line, and it ends up being the same exact thing. So it's right on top of this line. So in this situation, we say there's infinite solutions. And the reason why we say that, well, if we look at this first example, we said that wherever these lines touch, in this situation, just at this one point, that one point's the solution. But these lines touch everywhere. So we're going to have a solution at every single one of these points. So there's infinite number of solutions. So when you have a system of equations and you're solving it by graphing, when you graph, you're going to have one of these three situations, either parallel, they're on top of each other, or you're just going to have one solution. And so that's what we're looking for when we're solving by graphing. So let's do it with the example, fit it in right here. Say if we want to solve this system, x minus y is equal to minus 4, and then x plus y is equal to 12. So we want to graph these two lines and see where these lines either intersect, or see if this is the situation or see if that's the situation. So let's start just by graphing this top line. If we rewrite this top line, we can rewrite this as y is equal to x plus 4. So all we did here is we add the 4 over and add this y over. So this top line, that's the same thing as this one. Again, by adding the y over to the right and then adding this 4 over to the left. And we know that, well, this is just a, whenever we're graphing lines, you have the y equals mx plus b. This m is the slope and the b is the y-intercept. So this is the number in front of the x. Here is a 1, that's our slope. And this number at the very end, that's the y-intercept. So if we're going to graph this line, it has a y-intercept of 4. So here's 4. And then a slope of 1. So you go up 1 over 1. So see, here's the point, just 4. And another point on here, if we just move up in this direction, you go up 1 over 1. This will be 1 and 5. So this is the point 1 comma 5. So just a little sketch of the line. It looks like this. The second line, we can rewrite it as y is equal to minus x plus 12. Again, all we did here is just subtract this x over. And now we see that the slope is minus 1 and the y-intercept is 12. Okay, so it's all the way up here. Here's the y-intercept at 12. And the slope is minus 1, meaning we go down to the left and right 1. So we go down to the left, right 1. Here's another point on here. So this is going to be 11, 1. Or sorry, 1, 11. And we can connect those two lines. So in this situation, you see these lines intersect only at this one point right here. So that's going to tell us we're only going to have one solution. And the way we find this point is that, so after we graph these two equations and we see that we do have one of these points, when we have it in this form, the y equals, like your mx plus b form, you're going to set both of these equations together and solve for x. And that's going to give you this x point right here. And then we're going to plug that x back into one of these equations, and that's going to give you this y point, which is the solution. So to first define the x, we're just going to set these two equations equal to each other. So we'll have x plus 4 equals minus x plus 12. And if we add this x to the left and subtract this 4 to the right, we're going to get 2x is equal to 8. And if we just divide this 4 onto the right-hand side, we get x is equal to 4. So then this x value right here is actually equal to 4. And so now to find the y value, we need to plug this 4 back into any one of these equations, either the first one or the second one, it doesn't matter. Let's say if we just plug it back into the first one, so the first equation was x minus y is equal to minus 4. If we plug in x equals 4, we're going to get 4 minus y is equal to minus 4. And then to solve for y, well, we can add this y to the right and add this 4 to the left, and we're going to get 8 is equal to y. So then this y value right here is actually equal to 8. And that's going to be the solution to this system of equations. It's going to be a point. The x is 4 and the y is 8, so we can write that as a point. So 4 comma 8. So again, when we solve the system of equations, we're looking for a point. We're solving for an x value and a y value. And so we get our x to be 4, or 8 to be y, or y to be 8, so we can write it as a point like this, the x part and the y part. Okay, so as far as solving by graphing goes, that'll be it. And then the next way we're going to solve these is going to be something called substitution. So this is solving by substitution. So we'll just do this by doing another example. So say we have x plus y is equal to 8, and then y is equal to 6 minus x. When we solve by substitution, what we want to do is we want to somehow, so we're going to given these two equations. And then we're going to want to just pick one of the equations, solve for a variable. So like in this example, the second equation is already given to us where it's solved for y. We have y is equal to something. So once we're in that situation, we want to plug that y into the first equation. Meaning, so we know that here y is equal to 6 minus x. So what we're going to do is then take this and plug it into the first equation. So we're going to turn this y into a 6 minus x, and that's going to allow us to solve for x. So sort of the main idea is we're going to be given, again, two equations. Say ax plus by is equal to c. So there's equation 1, or let's do this, a1, b1, c1. And then a2x plus b2y is equal to c2. So this is sort of just the general form here. This a1, a2, b1, b2, c1, c2, these are just numbers. So this could be, equation 1 and equation 2. So when we're solving by substitution, we first just pick any equation, pick either 1 or 2. And it doesn't matter which one you pick. Some situations it's going to be easier to pick one of them over the others, but that just depends on the problem. But either way, if you pick either one, you'll get the right answer. And then once you pick either equation 1 or equation 2, you just pick a variable from that equation to solve for. So pick either x or y and solve for it. Meaning, when you solve for it, meaning you want to have either, if you pick x, you want to have, x equals, some stuff. And if you're going to solve for y, you're going to have y is equal to some stuff. And then once we solve for that variable, either we solve for x, we solve for y, we're going to plug this back into the other equation we didn't choose. So whatever equation you choose, you solve, say if we chose equation 1, we solve for x and y, whatever one we chose for, and then we're going to plug that variable into equation 2, the one we didn't choose. So now we're going to plug this variable, so plug this into the other equation and solve. All right, so let's do these 3 steps with this equation over here. So we either want to pick equation 1 or 2, and the second one is pick either x and y and solve for it. So if we look at this example over here, well, equation 2 is going to be the one that we're going to want to choose because it's already taking care of step 2 for us. We already have y is equal to some stuff. So you see here, equation 1, we have this, but equation 2, we already have y is equal to this. So this is already given to us, solved for y. So what we're going to want to do is pick equation 2. It's already solved for y, and now we're going to plug this y into equation 1. So instead of writing x plus y is equal to 8, this is just equation 1. We're going to want to replace that y with 6 minus x. So we're going to write this as x plus, we're replacing y with 6 minus x, and it's still equal to 8. So all we did here is, again, replace this y with this y. This y is 6 minus x, so we're going to turn this y into a 6 minus x. And now we're going to solve this equation for x. So since that has a plus sign, we can just get rid of these parentheses, and we have x plus 6 minus x is equal to 8. And here we see that we have x minus x, that's just going to be 0. So really all on the left-hand side we have is a 6. So 6 is equal to 8. But you see, we got into a situation here where we got a number is equal to a number. And well, this isn't true. We have 6 is equal to 8. So this isn't true. And whenever this happens, so this brings up another point that we'll, after we finish this problem, we'll talk about. If you're ever doing these problems and you get to a situation where you get something like this, so 6 is equal to 8, so like one number equal to another number, but they're not the same thing, like you get something that isn't true, this means we're going to have no solution here. So as far as solving by substitution and also the next method, we kind of have these guidelines. So say if we do all our work and we somehow get, x is equal to a number, y is equal to a number, then that's okay. This means we're going to have one solution. We'd have x be this number. These are 2 different numbers. So here's like number 1, here's number 2. That means we're going to have one solution. Another situation we're going to have is we're going to have, say some number 1, and it's also equal. We do some work and we get that number 1 is equal to number 1. So maybe we do some work, instead of having this be 6 equals 8, we somehow get 6 equals 6. So whenever you do all this work and you end up getting the numbers equal to that same thing, this means we're going to have infinite solutions. And then the last situation is the situation we had here, is when we got a number, so number 1, and somehow we did some work and we said that was equal to some different number, number 2. Like here 6 is equal to 8, which obviously isn't true. And whenever that's the situation, we're going to have no solution. So these are the 3 situations that we'll have for this method, solving by substitution, and then also the next method we'll talk about. Is either we're going to get x and y are just 2 different numbers, or they can be the same number. We can have x is equal to some number and y is equal to the same thing. That's fine. That means one solution. Or we're going to do some work and we're going to get either something like this, some number is equal to a different number, which isn't true. so that's no solution, or we're going to get the same thing is equal to each other, which means infinite solution. And then once you get one of these three things, either one solution, infinite solution, or no solution, the problem's done. So we tried to solve this problem, but we see that there's no solution to this. So there's nothing else we can do. Once we get no solution, we move on. So we're going to do one more solving with substitution. So the next example let's do is 2x minus 3y is equal to 2. Here x plus y is equal to 1. So again, we want to solve this by substitution. So if you remember the steps where we want to pick one of these equations and then solve for one of the variables and plug that into the other equation. So let's call this, here's equation 1 and here's equation 2. It's going to be easiest for us to pick equation 2 because it's much easier to solve for this x and this y, or which other one we choose for, versus solving for the x and the y up here. So the equation up here has numbers multiplied to the x and the y. So there's going to be more steps if we want to solve for x or if we want to solve for y. So the first thing we want to do is just pick equation 2. And then we can choose either variable to solve for. We can either solve for x or we can solve for y. It doesn't matter. We'll just choose to solve for x. And then we're going to solve for x. So we take our equation 2, x plus y is equal to 1, and we want to solve for x, meaning just get x on one side, everything else on the other side. If we just subtract this y over, we're going to get x is equal to 1 minus y. So once we have that, the x is equal to 1 minus y, we're going to take this and plug it into the first equation. So now we're going to plug this into the first equation. So the first equation, let's just rewrite it. We have 2x minus 3y is equal to 2. And now we're plugging in this x equals 1 minus y into here. So instead of writing an x, we're going to write 1 minus y. So we'll have 2, 1 minus y, minus 3y is equal to 2. So we still have the minus sign, we still have this 3y, we still have this 2. But now we want to solve for y here. Oh, we have one equation now and one variable, so we can solve for that variable. So in order to solve for y, first we want to distribute this 2. So we're going to have 2 minus 2y, then minus 3y is equal to 2. Then we can combine this 2y and minus 2y minus 3y, so it's going to be 2 minus 5y is equal to 2. We could subtract this 2 over, so we're going to get minus 5y is equal to 0. And then if we divide the minus 5 over to the right, we get y is equal to 0. So now, so we have y is equal to a number. So you look on the previous page, you had these three situations. Either a number is a number, one number is equal to a different number, or we have a situation like this. So this is what we're going to have. So here we have y is equal to a number. So we get y is equal to 0. So we know one of the solutions so far, y is 0, but we have to figure out what x is. So then what we do is we take this and we can either plug this into equation 1 or equation 2. So now plug into either 1 or 2, it doesn't matter which one, and then solve for x. So let's just plug this into equation 2. Equation 2 has a smaller number, so it's going to be easier to work with. So equation 2, that is x plus y is equal to 1. But we know y is 0. Let's write that up here. We know y is equal to 0 now. So what we can do is just plug this in here and solve for x. So we're going to get x plus 0 is equal to 1. Well, that just means x is equal to 1. So we get our other solution. So what we just found was that by doing this method, we get y is equal to 0 and x is equal to 1. Or if we write this answer in like an ordered pair, it's going to be the point 1 comma 0. So in this situation, we just have one solution, and then the solution is going to be 1 comma 0. So the last method in order to solve these is called elimination. So this is solving by elimination. Okay, so let's do a couple of examples with this. The first example we'll do, let's solve this one. 5x plus y is equal to minus 8, and then 7x minus 3y is equal to minus 42. So when we solve by elimination, what we want to do is, so there's a series of steps. the first step we want to do is just pick a variable. So pick either x or y. And the whole goal is we want to get the number, say if we want to pick the variable y in this equation. The whole goal is we want to have the number in front of this y and the number in front of this y either be the same thing, or one of them be like the positive version and the other be the negative version. So like here we could put like a 3 in front of here and have a -3 in front of this one, that's fine. We just want the number in front to either be the same or the negative of each other. So say if we chose x, we'd want to either somehow turn this 5 into a number that would be the same thing as we could turn the 7 into. We'll see that more as we do this example. But the next thing we want to do is then, so make the number in front of the chosen variable the same. And the way we do that is we multiply the entire equation by a certain number. So just for example over here, which we'll do in a second, if we multiply this entire top equation by 3, so we multiply this 5 by 3, this 1 by a 3, and this 8 by a 3, then the numbers in front of the y are going to be the same. So if we multiply this 1 by a 3, there's going to be a 3 here, so there's going to be 3 up here and a 3 down here. So that's the way we make the variable we choose have the same number in front of. And the last thing we do is either add or subtract the equations. And then we'll talk about in a second when are we going to add and when are we going to subtract. So it's either going to be one or the other, and this depends on the type of problem you have. So let's start by doing this problem. We want to pick a variable, either x or y. It's going to be easiest to pick y in this situation because it's going to be easy to put a number in front of y that's going to be the same as this one. If we chose x, we would need to do something to this equation and also do something to this equation to turn this 5 into a number that's the same thing as this 7. So for this situation, we're just going to pick variable y. So we're going to pick y. And what we can do, so let's call this equation 1 and this one's equation 2. In order to get the number in front of this y, like we said a second ago, to be the same as this one, we can just multiply 3 by this top equation. So we could take 3, multiply it by the top equation. And then doing that, so we're going to get 3 times 5, which is 15, so 15x. 3 just times y, which is 3y. And then 3 times minus 8, which is minus 24. So now this top equation looks like this. And now let's just rewrite the bottom equation beneath of it. 7x minus 3y is equal to minus 42. So you see now we turn this is the old first equation, but now we made it so that the number in front of the y is the same as the number in front of the y in the second equation. Well, just the negative of each other. And that was the whole goal. So we took our top equation, we multiplied it by a number to make that happen. And so now once we do that, we either want to add or subtract these equations. So the whole goal is to eliminate this variable y. So since this is a plus and this is a minus, if we were going to add these two equations together, the y would go away. So in this situation, we're going to want to add the equations. Say if this was the same, this was a positive 3 and this was a positive 3, then we'd want to subtract the equations to eliminate the variable. So if we add these two equations together, we'll get 15x plus 7x, which is 22x. And then if we add minus 24 and minus 42, we get minus 66. Okay, so now it's easy. To solve for x, we just divide by the 22, and we're going to get x is equal to minus 3. Okay, so there's our first answer. We get x is equal to minus 3. And now what we do, just like in the last one, we're going to either plug this into either 1 or 2, so either the first equation or the second equation, and solve for y. So just like before, it doesn't matter if we plug this into 1 or we plug this into 2, just pick one of these equations and then we'll solve for it. So let's say if we plug this into the first equation. The first equation is this, 5x plus y is equal to minus 8. If we plug this x equals minus 3 in, so now we're going to have 5 times minus 3 plus y is equal to minus 8. So 5 times minus 3 is minus 15. So we're going to have minus 15 plus y is equal to minus 8. And then if we add this 15 over to the other side, we're going to get y is equal to 7. So there's the y part of our solution. So then we just found this one has one solution. We have x is minus 3 and y is positive 7. So our solution is minus 3, 7. Okay, we're going to do one last example for solving by elimination. So the last example, let's do 3x minus 6y is equal to 15. And 2x minus 4y is equal to 10. So we want to do the same thing as just last time. We want to pick an equation and then pick a variable and then eliminate that variable. So you see in this problem, there isn't really an easy one to choose. There isn't an equation. We can't easily just turn this 3 into a 2 or this 6 into a 4. So either variable we choose, either x or y, we're going to have to do something to both equations to make the number the same. So let's just choose the x. Since the x has smaller numbers in front of it, it's probably going to be easier to work with. So we're going to choose the x, and this is the variable we want to eliminate. So choose x to eliminate, meaning that we want to figure out how can we get a number in front of this x and a number in front of this x to be the same thing. So let's multiply the top equation by a 2. And at the same time, let's multiply the bottom equation by a 3. So doing that, we're going to have 2 times 3, which is 6, so 6x. 2 times minus 6, which is minus 12, so minus 12y. And then 2 times 15, which is 30. On the bottom, we're going to have 3 times 2, which is 6x. 3 times minus 4, which is minus 12y. And then 3 times 10, which is 30. And then now what we're going to do, so we see we have a 6 in front of this x and a 6 in front of this x, so both the same thing. So in order to eliminate those, we're going to want to subtract these two equations. So we want to take this equation and subtract it from this equation. So doing that, and this, we need to put parentheses here because we're going to do 6 minus this, we'll do minus 12 minus that, and then 30 minus that. But you see what's going to happen here, which is just in this situation in particular. So we're going to have 6 minus a 6x, which is 0, minus 12 minus a negative minus 12, so just minus 0, and then 30 minus 30, which is 0. So we get 0 is equal to 0. So if you look back, what we just did is we have this situation now. We have a number equaling the same number. We have 0 is equaling 0. So in this situation, that means we're going to have infinite solutions. And whenever this happens, the way we write our solution, there's two ways. So on the online homework, it's either going to give you something that looks like this. It's going to be x, and then an empty spot where the y is, or it can give you an empty spot where the x is and y. And so we'll do this problem for both of these situations. So what we do is once we see that we have infinite solutions, we go back to our original problem and just pick any of the equations. It doesn't matter which one. We could just choose the second one. And if we have this situation, this means we want to have, the number we want to put here is going to be, so we want to solve whatever equation we choose, we want to have it solved for like y is equal to some stuff. And whatever this stuff is, that's going to go right here. So we're going to solve this equation for y, and whatever we get on the other side, that just goes right here. In this situation, we're going to want to solve for x. So we're going to have x. We're going to solve for the x here, so add the 4y over, and then somehow get x alone. So we're going to have x is equal to some stuff, and then that's going to go right here. So again, let's do that for both of these examples. So we'll take this, it doesn't matter which equation you choose either. Let's just choose the second equation. So we take 2x minus 4y is equal to 10. And in this situation, we want to solve for y, and whatever we get, we're going to put right here. So if we solve for y, what we can do is add this 4y over, and at the same time subtract the 10 over. So we'll get 2x minus 10 is equal to 4y. So again, we just added the 4y over and then subtracted the 10 over. And now to solve for y, we'll just divide 4 onto both sides. So we get 2x minus 10 over 4 is equal to y. But so up here we see we have y is equal to some stuff. That's what we have now. Y is equal to this. So this right here is like the stuff from above. So the way we write our answer then is x, and then we put this piece over here, 2x minus 10 over 4. So this is one way to write the answer. Another way to write the answer is, say if the problem wanted you to do a y and then you have this thing over here. So we need to solve for x now. So we take the same equation, 2x minus 4y is equal to 10, and we want to solve for the x. So we want to add this 4y over. Then we're going to divide by the 2. So now we have x is equal to this piece over here, and above this is the stuff. So then we write our solution as, so this piece just goes here. Then we have our comma y. And so this is another way to write the answer. And both these things mean the same thing. So lastly, there's just one thing to talk about, a couple of definitions that are used on the homework. And that's going to be either consistent, so consistent, and inconsistent. And so what inconsistent means, this is another way of saying that there's no solution. But with consistent, this means that there is a solution. And when there is a solution, then there's two more other words that are used. It's either going to be a dependent, or you're going to have independent. So dependent, this is going to happen when you have infinite solutions. And then if you see the word independent, that just means one solution. So on the online homework, when it asks you, is this consistent or inconsistent? If you get no solution, that just means consistent. Let's put this down like that. And if you get if you get a solution, either there's infinite or only one of them, that's going to depend on this. So if you have infinite solutions, that means it's going to be dependent. And then if you have one solution, it's going to be independent. So that's what these words mean from the homework. Okay, and that's everything from section 6.1.